This conference will now be recorded.
Hi, and thanks for joining me. We're going to talk about Section 312.5C of the 2020 National Electrical Code. My name's Ryan Jackson. Ryan Jackson Electrical Training is my business. You can like me on Facebook. You can visit my webpage, ryanjacksonelectrical.com. Email me, ryanjackson618@gmail.com if you'd like to get in touch with me. So 312.5C is what we're going to be talking about today. It's a very misunderstood section. The general requirement is easy enough, but the exception is very misunderstood and very misapplied. So let's make sure we're in the right article. Article 312 covers cabinets, meter socket enclosures, and cutout boxes. Now, a cabinet is the enclosure that you put a panel board in, right? The panel board is the guts, the bus bars where the breakers go in. The cabinet is what the panel board goes into. You also have meter socket enclosures in 312. That's easy enough, right? That's where the meter goes. And then you have cutout boxes, which would be like a fuse disconnect where you cut out the power. So in this photograph, here on the left, we have a device box that is covered by 312. That's not Article 312. That's covered by Article 314, not 312. This cabinet here is covered by Article 312. Now, this rule says each cable must be secured to the cabinet, cutout box, or meter socket enclosure, and you can see each of those cables is in fact secured. Easy enough. Here we have another example of the same requirement. We've got a cabinet for a panel board, multiple cables going into it, and they're all connected to that cabinet. Now, how many cables can go through a connector is not something that the NEC tells us. That would be up to the manufacturer of the connector. 334.6 requires that the connector be listed. And once we have listed products, 110.3b says that we have to follow the instructions. So look at the instructions and see how many cables you can get through there. I know of one manufacturer that specifies multiple cables. And I would recommend using that because, how many is multiple? More than one. So as many cables as you want, as long as you can tighten it up. That's the one that I would use. So the general rule here is easy enough. Each cable has to be secured to the enclosure, fine. Here's where people get hung up, exception number one. And depending on what part of the country you live, you may see this every day, or you may never see this. In my area, very seldom do you see this. But what people do is they want to sleeve their cables going through a conduit. And you can do that, but there's seriously about 15 different requirements in order to meet this exception. So you can do this with non-metallic cables. That's the first part. Can't do it with MC cable or AC cable. It's only for non-metallic cables such as NM cable. So NM cables can enter through the top, not the sides, not the bottom. It can enter through the top of a surface mounted enclosure. So if your panel is in the wall, can't use this exception. It's only for surface mounted enclosures using non-metallic cables, surface mounted through the top of the enclosure through a non-flexible raceway that's at least 18 inches long and not longer than 10 feet. So far, we've got 5 things that we have to comply with. Non-metallic cables, top of the enclosure, surface mounted enclosure, non-flexible raceway, 18 to 10 feet long. And we haven't even started yet. And we've already got 5 things we have to do. In addition to those 5 things, each cable has to be secured within 12 inches of the raceway. So the cables go through the raceway, they leave the raceway, and up here within 12 inches, they have to be secured. Number 2, the raceway is not allowed to penetrate a structural ceiling. And looking at this, looks like we comply. This does not penetrate a structural ceiling. The structural ceiling would be the bottom of those eye joists. So we're good on item 2. Number 3, a fitting has to be provided on the ends of the raceway to protect the cables, and it has to remain accessible. These have fittings on them. As you can see, they've got bell ends, and they're not concealed behind drywall or other finished material. So far, we're meeting the code on this installation. Item 4, the raceway has to be sealed at the end, and it is. Inside of these raceways, we've got duct seal, the gray kind of putty material, so that's good. And then item 5, the cable sheath must be continuous through the raceway and extend into the enclosure at least 1/4 of an inch. We can't strip the jacket and just push the wires down. It's got to go all the way through the raceway, at least 1/4 inch. Number 6, the raceway must be secured. Okay, strap, 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 strap. We're good there. And then item 7 is usually the deal breaker. The cable fill must not exceed table 1 of chapter 9 and its notes other than note number 2. So we have to deal with raceway fill, and this is where people really screw this up. You can't just stuff as many cables in there as you can fit. You're going to be way overfilled if you do that. If we look at this example, I circled the one that we're going to work through because to me, that one looks like the one with the most cables. We have ourselves a PVC raceway. It's at least 18 inches long, and it may not look like it, but it actually is. It's exactly 18 inches long. The guy who did this is a guy named Phil Mazzara. It's a great installation, by the way, and he posted this on Facebook, and I immediately said, this is a violation. And he insisted that it wasn't, and I said, oh yeah, well, I'm going to do the calculations, and I'm going to show you why this doesn't comply. And we're going to find out who was right and who was wrong. But he said, listen, this is exactly 18 inches, and we can see that it's less than 24 inches long. Now, the fact that it's less than 24 is really important because with a 24-inch raceway, I can go up to 60% cable fill, and we're going to really rely on that 60% allowance. So in this raceway, we've got 11 14-2 cables, and we've got 7 12-2 NM cables. Table 1, Chapter 9 allows for up to 40% when we have more than 2 conductors, but Note 4 allows us to go up to 60% if the raceway is 24 inches in length or less, and this one is. When we keep reading, though, we find something that becomes a major problem really quickly, and that is table note number 9 requires elliptical cables, so cables that are flat like this, to be calculated using the long dimension of the ellipse as the diameter for determining cross-sectional area. So we're going to pretend that this cable is circular, but we're going to pretend that that diameter applies all the way around it. So that's how we're going to figure out the size of the cable. And then we're going to go to table 4 in chapter 9 to figure out what size raceway we need. So this is a chart that I downloaded from a very popular cable manufacturer, and it shows the diameters of their cables. For 14-2, it's 0.39 inches wide. For 12-2, it's 0.45 inches wide. But the diameter is only half the game. We're not doing anything based on the diameter, we're doing it based on the area. And the first time you do this, if you're like me anyway, you're going to forget to change it from diameter to area. When we go from diameter to area, we need the formula pi r squared, right? So radius squared times pi is the area of a circle. Struggling here. So for a 12-2 like the one in my hand, the diameter is 0.45 inches. So let's get the calculator out. 0.45 inches. We're going to divide that by 2 to get the radius, right? So the radius is half the diameter, and that's 0.225 inches. Once we have the radius, then we need to square it. So we're going to times that by itself. So 0.225 times 0.225 equals 0.05. That's our radius squared. We're going to multiply that by pi to get the area. So times 3.14159. I don't know why I choose 5 digits for pi. You could easily just do 3.14, and it's just that's the length of pi that I memorized, and I've just always used it. So the area of each cable is 0.159 inches. So that's for each. We know that we had 11 of these 12-2 cables, so we're going to multiply that by 11, which means our total fill for all of our 12-2s is 1.749. Let's call it 1.75. So that's my area for my 12-2. So I'm going to write that number down, 1.75. But we also need to do our 14-2s. And our 14-2 cable, we decided was 0.39 inches in diameter. We don't care about the diameter, we care about the radius, and that's half that number. So 0.39 divided by 2 equals 0.195. We don't care about that number either. We care about that number times itself. So the radius squared, 0.195 times 0.195 is 0.038. That's our radius squared for each cable. We're going to multiply that by pi times 3.14159. Each cable has an area of 0.119 inches. We had 7 of those cables, so we're going to times this number by 7. The total area consumed by all of our 14 twos is 0.836 inches. All right, so we're going to write that number down. We're going to add the two together. So 1.75 plus our 0.836 plus 1.75 is essentially 2.586, and we're going to round it at that point. So we need a conduit at 60% that can accommodate 2.586 inches. We go to table 4 in chapter 9. We look through the headings and we make sure that we're using the right table. It's not enough to know that we're using rigid PVC conduit. We need to make sure we're using schedule 40, not schedule 80, because schedule 80 has a smaller internal diameter than schedule 40. We already established that we can use the 60-degree column. I need 2.586 inches of accommodation. I go down here, trade size 2 is too small. Trade size 2.5 is just right, 2.8. So that's how we do this calculation. So who was right, me or Phil? I said right off the bat that this was wrong because, quite frankly, I've never seen one that actually complied. And looking at it from a distance, it looked like it was too much. This actually complied, not by much, but doesn't matter. It either complies or it doesn't. So Phil Mazzara, who did this installation, great job. Looks clean as a whistle, it's code compliant, well done. We also added an exception in the 2020 NEC that I'm going to talk about really quick, and that is single conductors or multi-conductor cables leaving cable trays can enter enclosures through a raceway or flange without being secured to the enclosure. This is something that, I don't know, we haven't talked about it in the code. It probably should have been in the code for 100 years because that's how long we've been doing it. But we leave the cable tray and we enter an enclosure. Very, very common to do this through either a raceway or over here on the left through a flange. Either way, accepted practice, and now it's allowed by the NEC. Thanks for watching. Thanks to Phil Mazzara for the installation pics. By the way, if you're proud of an installation, email it to me. Maybe we can use it in a video. So thanks for watching, everybody. Have a great day.